let us proceed with some more examples for practice. We are seeing some examples here. First example states that a 8-stage axial flow compressor provides an overall pressure ratio of 6.5:1 with an overall isentropic efficiency of 82%. A temperature of air at inlet is 292 Kelvin. The work is equally divided between all the stages. Compressor has 50% reaction with a blade speed of 225 meter per second and constant axial velocity of 145 meter per second. Estimate the blade angles. Assume work done factor to be 1. In this example, given things for us are number of stages 8, compressor's isentropic efficiency is 82%, then we are told that U is equal to 25 meter per second, lambda is equal to 0.5, pressure ratio is 6.5 and temperature T01 292 Kelvin. We have U, we have axial velocity 145 meters per second. Okay, having said this, we will proceed. So we know delta T naught overall is equal to T01 divided by compressor efficiency into Rp raised to gamma minus 1 upon gamma minus 1. This example we are solving for air, so gamma will be taken as air unless otherwise said. Further, we are working for compressor, so we should take gamma as 1.4. The same gamma will change to 1.33 in case of turbine, since we will have reacted products as gases flowing through the turbine. This is overall temperature ratio, temperature change, but this overall temperature change, for that it is said that work is equally divided between the stages. So temperature change is equally divided between the stages, and this gives us delta T naught stage. So delta T naught stage is delta T naught overall divided by number of stages. So we can find out delta T naught stage, and it is equal to 292 divided by 8 stages, compressor efficiency 0.82, pressure ratio is 6.5, bracket raised to 0.4 divided by 1.4 minus 1. So delta T naught stage is equal to 31.47 Kelvin. Hence we can get T03 is equal to T02 plus delta T naught stage, delta T01 plus delta T naught stage, hence it is 323.47 Kelvin. We are expected to find out blade angles, so for that we can make use of new formula, which is delta T naught stage, and that is equal to work done factor U into Ca divided by Cp into tan of beta 1 minus tan of beta 2. So we know delta T naught stage is 31.47, work done factor is 1, U is 225 and Ca is 145, Cp is 1005 into tan of beta 1 minus tan of beta 2. So we get tan of beta 1 minus tan of beta 2 is equal to 1.55. We don't know both tan of beta 1 and beta 2. So we will name it as equation number 1. Further, we can make use of the expression for degree of reaction, which is lambda is equal to Ca upon twice u into tan of beta 1 plus tan of beta 2, but we know we are working with degree of reaction half. So it turns out to be u upon Ca is equal to tan of beta 1 plus tan of beta 2. We know u, and u is 225, Ca is 145, so u upon Ca is 1.55. We will name it as equation number 1. So we have tan beta 1 plus beta 2, we have tan beta 1 minus tan beta 1 minus tan beta 2 is equal to 0.9694. So we have tan beta 1 minus tan beta 2, we have tan beta 1 plus beta 2. So we can solve these equations simultaneously, and we can get twice into tan beta 1 is 2.52, which gives us tan beta 1 is equal to 1.26. So we have beta 1 is equal to 51.56 degrees. Similarly, we can get tan of beta 2 is equal to 1.55 minus tan of beta 1. So this gives us tan beta 2 is equal to 0.29, and hence beta 2 is equal to 16.17 degree. So we got the required thing from the example. We will move on to the next example. It reads that an axial air compressor of 50% reaction has blades with inlet and outlet angles of 47 and 12 degrees respectively. The compressor is to produce a pressure ratio of 5.5 as to 1 with an overall efficiency, isentropic efficiency of 0.87. When inlet temperature is 30 degrees Celsius, the blade speed and axial velocity are constant throughout the compressor. Assume a value of 220 meter per second for blade speed. Find out number of stages required if work done factor is unity. So for all this sake, whatever we are given with, we can make use of. We are given that pressure ratio is 5.5, isentropic efficiency is 0.87, T01. We are told that it is 303 Kelvin. Then we are told that beta 1 is equal to 47 degree and beta 2 is 12 degree. U is 220 meters per second. Lambda is equal to 0.5, work done factor unity. So these are the things which are given. Now we first find out overall temperature change from the efficiency formula. So T01 upon isentropic efficiency into Rp raised to gamma minus 1 upon gamma minus 1. So T01 is 303, isentropic efficiency 0.87, so 5.5 bracket raised to 1.4 minus 1 divided by 1.4 minus 1. So we can find out overall temperature change in the compressor, and that turns out to be 218.55 Kelvin. Now we are supposed to find out the stage temperature change, and then we can divide them and find out number of stages. The formula for stage temperature change is lambda work done factor into U into CA divided by Cp into tan of beta 1 minus beta 2. But in this formula we are not aware about Ca1. So to find out Ca1 we can make use of degree of reaction, which says that lambda is equal to Ca upon twice U into tan of beta 1 plus tan of beta 2. So we will have tan of beta 1 plus tan of beta 2 is equal to U upon Ca. So Ca is equal to U divided by tan of beta 1 plus tan of beta 2. We know U, it is 220 meter per second, tan beta 1 which is tan of 47 degree and it is 1.0723 plus tan of beta 2 which is tan of 12 degree which is 0.212, and then it gives us Ca as 171.22 meters per second. This helps us to find out delta T naught stage. So we know work done factor is unity, U is 220, Ca is just now found out as 171.22 divided by Cp which is 1005 into tan beta 1 is 1.0723 minus 0.212 which is tan of beta 2. Delta T naught stage is equal to 32.24 Kelvin. Thus we can find out delta number of stages as delta T naught overall divided by delta T naught stage. So N is equal to 218.55 divided by 32.24 and this is 6.77. So we have to use 7 stages to achieve this required pressure rise of 5.5 total pressure ratio. We will move on to the next example, and this example says that find the polytropic efficiency of an axial compressor from the following data. The rotor and stator are symmetrical. We know that when it is said the rotor and stator blades are symmetrical, it means that degree of reaction is 50%. The mean blade speed and axial velocity remain constant throughout the compressor. Assume a value of 100 meter per second for blade speed and work done factor of 0.84. Find number of stages required. Also find the inlet Mach number relative to the rotor at mean blade height. So for this data given is total pressure inlet head is 6.5, overall total head inlet pressure ratio is 6.5, overall head isentropic efficiency of compressor 90%, total head inlet temperature is 292 Kelvin, inlet air angle from the rotor blades is 12 degree, outlet air angle from the rotor blades is 43 degree. So we can write down given things. Pressure ratio is 6.5, overall isentropic efficiency is 0.9, T01 is 292 Kelvin. We are told that air angles as alpha 1 as 12 degree and alpha 2 as 43 degree. Blades are symmetrical, so lambda is equal to 0.5, hence we can mention the same thing as beta 2 is equal to 12 degree and beta 1 is equal to 43 degree. We are told that u is equal to 200 meters per second and work done factor lambda is 0.84. With this we will proceed. We know isentropic efficiency of an axial compressor can be written as Rp raised to gamma minus 1 upon gamma minus 1 divided by Rp raised to gamma minus 1 upon gamma into compressor's polytropic efficiency, its ratio its reciprocal minus 1. We know isentropic efficiency is 0.9, pressure ratio is 6.5 raised to 0.286 minus 1 divided by 6.5 0.286 divided by polytropic efficiency of compressor minus 1. So we will get from here 6.5 into 0.286 divided by polytropic efficiency of compressor minus 1 is equal to 0.7866. From here we can find out compressor's polytropic efficiency and it turns out to be 92.2%. So we first found out polytropic efficiency. Now we have to find out number of stages. Again we have to find out stage temperature rise and overall temperature rise. So we know for stage temperature rise, we know the formula, and that formula is delta T naught stage is equal to work done factor into U into Ca divided by Cp into tan of beta 1 minus tan of beta 2. We know alpha 1 is equal to beta 2 and alpha 2 is equal to beta 1, but here we are not aware about Ca. So we have to first find out Ca. We will make use of the formula for degree of reaction, which is 0.5, and this gives us U upon Ca is equal to tan beta 1 plus tan beta 2, which is also tan alpha 2 is equal to tan alpha 1, and then this we know this gives us 0.93 2125 plus 0.9325, and it gives us 1.1450. So we can know Ca is equal to U divided by 1.450, and it comes out to be 174.66 meter per second. So delta T naught stage can be found out now, and it is 0.84 into 174.66 into 200 divided by 1005 into tan beta 2 tan beta 1 minus tan beta 2 tan beta 1 is 0.9325 minus 0.2125, and this gives us stage temperature rise as 21.02 Kelvin. We can as well find out overall temperature rise and that is T01 upon compressor efficiency into Rp raised to gamma minus 1 upon gamma minus 1. So 292 divided by 0.9, 6.5 bracket raised to 0.286 minus 1. So overall temperature rise is 229.71 Kelvin. This helps us to find out number of stages, which is delta T naught overall divided by delta T naught stage. 229.71 divided by 174.66 divided by 21.02, and this gives us 10.92, which is 11 stages are required. We will move to next example. It states that air at a temperature of 288 Kelvin enters an 8 stage axial flow compressor at the rate of 5 kg per second. Pressure ratio is 5.5 and isentropic efficiency is 80%. Compression is adiabatic. The compressor has symmetrical blades. Again, degree of reaction is 50%. The axial velocity is 120 meter per second, which is uniform across the stage, and the mean blade speed of each stage is 185 meter per second. Determine the direction of air at entry to and exit from the rotor and stator blades, and also power given to the air. Assume Cp as 1.005 and gamma as 1.4. Let us mention what are the given things. Given things are pressure ratio is 5.5, T01 is 288 Kelvin, compressor's isentropic efficiency is 80%. It is told that Ca is 120 meter per second and U is 185 meter per second. Number of stages are 8, mass flow rate is 5 and degree of reaction is 0.5. We can find out delta T naught overall as T01 divided by compressor efficiency into Rp raised to gamma minus 1 upon gamma minus 1, 288 divided by 0.8 into bracket 5.5 raised to 0.286 minus 1. So now we have found out overall temperature rise as 226.2 Kelvin. So power required is equal to m dot Cp into delta T naught overall. M dot is said as 5 kg per second, Cp is 1005 into 226.2, and this gives us a number 1136.655 kilowatt. Now we can find out delta T naught stage, and delta T naught stage is work done factor into U into Ca divided by Cp into tan of beta 1 minus tan of beta 2. So U delta T naught stage we can find out from delta T naught overall divided by number of stages. is equal to, this is 1, work done factor U is 185, Ca is 120 divided by 1005 into tan of beta 1 minus tan of beta 2, but we know overall is 226.2 divided by number of stages is 8. So we get tan of beta 1 minus tan of beta 2 is equal to 1.28. We will number this equation as equation number 1. From degree of reaction 50, we know U by Ca is equal to tan beta 1 plus tan beta 2. So U is 185 and Ca is 120. So we have tan beta 1 plus tan beta 2 is equal to 1.5416. So we can solve equation number 1 and equation number 2 simultaneously, so that we can get tan beta 1 is equal to 1.41, and this gives us beta 1 is equal to 54.65 degree, and tan beta 2 is 0.1316. So beta 2 is equal to 7.49 degree. So this is how we would solve this example. We will move on to the next example. It reads that determine the stage efficiency and work done factor for an axial flow compressor if actual pressure ratio developed is 1.25 and actual temperature rise is 35 Kelvin. Blade inlet and outlet angles are 46 and 15 degrees. Peripheral and axial velocities are 280 meter per second and 195 meter per second respectively. Cp is 1.005 kilojoule per kg Kelvin. Gamma is 1.4 and total temperature at inlet is 295 Kelvin. So let us say what is given here, and given here is, actually it's a stage pressure rise, it is 1.25, T01 is 295, beta 1 is 46 degree, beta 2 is 15 degree, U peripheral speed is 280 meter per second, and the axial speed Ca is 195 meters per second. Having said this, we can find out the stage temperature rise, basically using the formula which is del T01 upon stage efficiency or compressor efficiency into Rp raised to gamma minus 1 upon gamma minus 1. Here we are given the stage temperature rise as 35 Kelvin, that is also given. So we can say stage efficiency is T01 divided by delta T0 stage into Rp raised to gamma minus 1 upon gamma minus 1. So stage efficiency turns out to be 295 divided by 35 into 1.25 bracket raised to gamma minus 1 upon gamma minus 1, and directly we get stage efficiency as 55.43%. Then we are supposed to find out work done factor. For that we can make use of the formula delta T0 stage is work equal to work done factor into U into CA divided by CP into tan of beta 1 minus tan of beta 2. So we have 35 is equal to work done factor into U is 280 into CA is 195 divided by 1005 and tan beta 1 is tan of 46 minus tan of 15. So we have work done factor as 0.8393. This is a simple example where we had to use straight formulas to find out the quantities. Thank you.